Today we are going to discuss our exercise 12b from day 2, chapter number 12. Previously we are discussing about volume of cone. So here in the question number 9, a conical funnel of diameter 23.2 centimeter and depth, depth is basically the height, okay, contains water filled to the brim. The water is poured into a cylindrical tin of diameter. So focus on the question. There are two shapes, one is conical funnel and the other is cylindrical tin. So it means you have to use both the formulas for the volume of the tin, volume of the cylinder and the volume of the cone. The water is poured into a cylindrical tin of diameter 16.2 centimeter. If the tin must contain all the water, find its least possible height. You have to find out the height. So here in the question number 9, you can see, first of all, I have find the radius by using diameter. Diameter is 23.2. I have divided by 2, so I get the radius. Depth is equal to height, so it is equal to 42 centimeter. Next again the radius of the cylinder, and you have to find the height of the cylinder. The first formula for the volume of the cone is 1 by 3 pi r square h. Put all the values in the formula and you will get the volume of the cone, because you know what is the value of radius and what is the value of height. The next you have to find the volume of cylinder, but the question they are given us the water is poured into the cylindrical tin. It means the volume of the cylinder and the cone is similar. So the volume of the cone, you used it in the volume of the cylinder. The volume formula for the cylinder is pi r square h. For the volume I have written 1883.84 pi, which is the volume of the cone, is equal to pi r, we know for the cylinder is 8.1 centimeter radius square, and h we don't know what is the height of the cylinder, so I put it as it is. The next on the both sides, here we have pi, so we can cancel out it and find the h by dividing both the values, and here is the answer. This is your h, height of the cylinder. Now let's move towards question number 10. In question number 10, a conical block of silver has a height of 16 centimeter and a base radius of 12 centimeter is given. The silver is melted to form coins 1 by 6 centimeter height, because it is the thickness, and thickness is the height, and one hole 1 by 2 centimeter in diameter. So this is your diameter. You have to convert this mixed fraction into the fraction. Find the number of coins that can be made. So in the question number 10, we are given again with a coin and a conical block. Conical block means cone shaped, and coin, of course it's a cylinder like shape. So here again height is 16, radius is 12. Both the values are of cone. I have written in the bracket. The height of the coin is 1 by 6. And diameter of the coin is 3 by 2. So I find out the radius of the coin, which is 3 by 4 centimeter. Volume of the cone is equal to 1 by 3 pi r square h. Put the values and find out the volume of the cone, which is 768 pi centimeter cube. Next you have to find the volume of the coin. Coin is a cylindrical, so put the formula of cylinder. Volume of cylinder is equals to pi r square h. Pi r square h, this is the answer of volume of coin. Next you have to find the number of coins. how many number of coins? So for this you have to divide volume of cone by the volume of coin. Volume of cone is equals to 768 pi over volume of coin is equals to 3/32 pi. Here is the mistake. So this is the number of coins. When you divide both the values, volume of cone divided by volume of coin, you will get the number of coins. Okay ji, this is your question number done. Next is your question number 11. An open cone has a circular base of radius 10 cm and a slant height of 20 cm. Draw the net of the cone and label its dimensions. Here you have a open cone having circular base of radius 10 cm and the slant height 20 cm. When you open the cone, you will see it becomes a semicircle, and for the circle you have to find the circumference. So circumference is equals to 2 pi r, which is a formula for the circle. The circumference is 2 pi r. 2 pi r, radius is 10 given. The circumference becomes 20 pi centimeter. So the other thing that is slant height divided by circumference. The slant height is 20 for the whole, you must say, for the whole figure. For the it's basically the slant height is equals to diameter. Okay, so slant height is equals to diameter and diameter is equals to 20, the double of the radius. Radius is 10, so when you talk about the diameter, it becomes 20. 20 divided by circumference, circumference is 20 pi, and you will get 1 by pi. But you have to make the cone with the semicircle, not with the whole circle. So here we are using the half circle. For it we are dividing it 1 by 2. 1 by 2 multiply by 10 over 20 pi, and for the 10 we are dividing, the 10 is the basically radius from center to the one edge. So this is your question number 11. Actually in the question 11 you have to just draw the net of the cone and label its dimension. So the labeling and the dimensions is this: the radius is 10 and your circumference is 20 pi. Okay, because it's the half, so you have to multiply it 1 by 2. Here we have. I hope so you will understand. Do these questions. In the next class we will do the other questions. You can try question 12. Hope so it will be done by you. Otherwise we will do it not in the class. Okay, exercise 12b, question number 11, 1 to 11 are completed.